Hey guys, Paul, Inventor 3. I'm back. Been working a lot on all different things here. Today I'm going to show you a little more details about this magnet dropping down a copper tube. Okay, let me turn around. All these post-its, all these old magnets. Those are all old magnets. The problem is I've had them all in this container and they wind up, and I'll explain a lot more about that, but their fields wind up getting distorted. These are some of my better magnets. Still very old, but I keep them lined up over here because they're apart, away from each other, not affecting each other as much. Now they're still going to be affected because of this being stuck to a pole, but there's nothing you can do about it. So anyhow, I'm going to show you this, guys. I was checking the times on these magnets being dropping down the tube, and they're all like messed up. They're really different. They're all over the place. I was going crazy, and I know it's because their poles and their fields are uneven now. So I wound up getting some brand new magnets, okay? And what I have here is 3 different sizes. They're all 5/8 diameter because that's what fits into our tube right here, okay? That's the idea of our tube, is a little over 5/8, but anyhow, so they're all 5/8 diameter. But let's see, these are 5/8 by 5/8. There's their fall time too. 5/8 by 1/2 inch. Thick or tall or height or whatever you want to call it. 5/8 by 3/8. Okay, now I'm going to show you right now. I'm going to show you the most interesting times right here. And the best time is with the 5/8 by 5/8. Now this is an N52. These are neodymium magnets. First of all, the rare earth magnets are the most powerful type you can get, and then there's the N42 or N52. N52 is basically the strongest magnets you can get. 5/8 by 5/8, and look at that difference there, and I'm going to show you that. Okay, this is a opposite poles attracting, which is normal. Okay, so we should see north and south. Okay, now let me show you that right now. I'm going to show you this. We're going to drop it down our tube right now. And now, you guys can watch your video time and check out how long this takes. Ready? 3, 2, 1, drop. Now, let's see. Unfortunately, the first foot wait, where's it at? Where's it at? Where's it at? There it is. Oh, it's hard to see in this lighting right now. Where is it? Where is it? Come on. I see it with my eyes. I hope you guys can see it on film. It's hard for me to see it on my camera. I don't have any more paper on there. I took off a whole layer of paper on there. Magnetic viewing paper, this is called. Okay, and so you could actually see it falling. Wait a minute. Where's it? There we go. Bloop. Check the time. Yeah, this is called magnetic viewing paper, and I'll show you more of that in a minute. These are 3 poles inside of each other. Alright, now you check the time on that. It should have been approximately about 36 seconds. Okay, now we'll put that one down. Let's take this one over here. Same poles glued together. Okay, it's north, north. So south and south are glued together. I'll show you how I do that too in a minute. But I want you to see this first. Yeah, I hope this is coming out on camera. I cut all the old stuff off because it was just not working anymore. You couldn't see it at all. So I put some new ones on. Well, not brand new. They're still old ones I had, but they were protected with layers of cardboard protecting them from the sunlight. Years being in the lights, it really kills them. Anyhow, they're really expensive though, so I didn't have enough. They're not brand new. I didn't have enough to put all the way down, so that's why I don't have them all the way down. Okay, ready? We're gonna go. Ready? This is super glued together. Remember, 3, 2, 1, drop. Oh, you just saw. Hold on. There it is. There it is. Where is it? Oops. There it is. Wait. Oh, man. Guys, you can't see it, can you? Hold on. Let's get this camera just right. Come on. Where are you? Come on. Get that angle just right. There, come on. Where are you? Oh, there you go. Okay. There we go. Now we can just, where'd you go? There you go. Still falling, guys. There it is. Woo! I know they had to have been over a minute. Yes. Wow. Okay. St. Paul's. There's the times that I got. Okay. Normal attracting poles, 36 seconds. Opposites glued together, 1 minute and 12 seconds. That's one of the best results. I could probably get it better. Alright guys, that's, well, let me show you this. There's lots to show you, but here's how I do it. I bored out this just a little bit with a drill. Make my magnets just fit inside there. Just fits inside. Just long enough. Stick one inside there, put a drop of super glue on it, then stick the other one on top. Then I take this rod and ram it down inside there and hold it for a couple minutes if I can. Sometimes it doesn't work, it doesn't stick. I have to sand it all off over and over again. It's frustrating. So it's not easy, but anyhow, I don't want to use a bolt or nothing through there, but that really shows it. Okay, now, here, let me show you this real quick. Alright, yeah, so that was our time with 3/8 thick, 1/2 inch thick, 5/8 thick. Okay, there's our tubes. There's the dimensions on our tubes. So take a screenshot or whatever you want there. Now think about this. The other two tubes on the outside are a foot smaller, a foot short. They're 5 foot. Right here. The other two tubes start here. The inner one is 6 foot. The other two tubes, the middle tube and the outer tube, are only 5 foot. So if I had them all 6 foot, we would get an even better time. I might even be able to add another layer on there. Okay, I'm going to show you the magnets that we just used, because we want to see them. I'm going to show you the magnetic viewing paper on them too. This is a normal pair, first of all, opposites attracting. Move my hand over this way so the camera focuses in a little bit more. So hopefully you can see that there's close to 6,000 Gauss. There it is, 6,000 Gauss on that side. It should be close to this. Negative and south pole. Okay, let's check over here in the middle. Very low, very low. 500. Okay, now let's real quick see what that looks like. You can see its division line. This side, and the opposite side, the division. Okay, now let's take a look at the one that we compressed the fields on. Here's, whoops, let's make sure we got this okay. I still got 5,000 Gauss on that side. I'm surprised. Yeah, about 5,000 Gauss on each side. But now, let's see the center. Right, yeah, it'd be a negative. Yeah, south. Oh, look at that. 9,000 Gauss I had there. 9,000. Look at that. 9,000. It's almost like it kept. Wow, and wow, you got so much more energy out of that now, didn't you? If you think about that as energy, wow. I think it was 6,000 on each side of the other magnet, but now this one's 5,000. So like, oh, okay, you lose 2,000, yeah, but you gain 9,000 over here. Let's see what that looks like under our paper now. Look at that. You got two division lines now. It's not showing in the middle. I should have looked at this first. I forgot about this. Wow. Yeah, look at that. Oh, now it's more defined, I think, that circle. But look at that. Let's look at the other one more time. Yeah. Five, maybe 6 at the most. Yeah, 6. Yeah. Wow. You sacrificed 1,000 Gauss on each end of the magnets. In return, you're gaining 9,000 Gauss on the inside. So anyhow, guys, I just find that really interesting. And let me move on to the next thing. I want to show you this. Watch. First of all, I'm wondering if I can even draw this. First of all, well, you got a division here. Something. Come on, don't stop working on me. Like that. But then is there also fields here? Huh. That needs to be studied more. Interesting. Something to that effect. Anyhow, all right, let me show you a little more. Okay, now this is a killer magnet, killer neodymium magnet that I had from years ago. It's all kind of rusted. You can see the north and south division. That's why I have a marker line on there. But anyhow, let's see now. Let me show you this cool magnet. I only got so many of these, but I'll sacrifice one. I think these were made for stators or something. Stator motors. Look at that. That's actually north, south, north, south, north, south, north, south. Pretty cool, huh? I had it a little too close to another magnet. Let me show you that. Oops, you should actually see positive and negative readings. Negative, positive. Negative, positive, negative, positive. So anyhow, you can see. But now, pretty cool, huh? Alright, anyhow. Now watch this. I'm going to take this magnet here. One pole. Okay. Real quick here. Stick it on there, circle it around. Oh, look at that. All our divisions are gone. So see, guys, hang on, this is important here. Okay, so that is why, exactly why, I bought all brand new magnets for this experiment here, so that you guys can see this. You can't use those magnets that I have sitting in a tube there all mixed up together. They affect each other. Those fields get manipulated. Look, guys, this is so important too, because it's like just improving the ordinary regular motor out there. Do you guys ever, have you ever tried this trick? You can take a magnet, go up to any motor, and I'm not suggesting anybody do this, okay? Do not do this, matter of fact. But if you go up to a motor and you put a magnet on it sitting there, you got to kind of move it around the outside diameter motor to kind of get it in line with the other magnets inside. You'll know, because all of a sudden you'll hear your motor go, and you'll get more energy out of it. A lot of people, just manufacturers, use cheap magnets. See, if they knew any better, there's a 1 second, couple seconds, you could take another magnet, even electromagnet, and just subject those magnets that they're already using to manipulate those fields so they go into the motor, the windings more, or even use like a Halbach type array so that the fields go in more, and they wouldn't be sacrificing buying better magnets, but you would just be able to manipulate the field in there to get a more efficient motor. Believe me, I got so many different ways I could improve on an ordinary mower. So anyhow, that's very important, guys. A field of a magnet can be manipulated very quickly. That just made me think about the Earth and solar flares. Anyhow, just wanted to show you real quick too. Here's the end of my tubes. Oh, the third one's in there, but you can't see it. It's like a ½ an inch inside. But there's my tubes. There's a third one in there. The third one fits very close to the middle one. Just wanted you to see that. The other reason I just wanted to explain real quick too is, now again, it's all about those eddy currents. I've done many experiments. Hold on, let me show you this real quick. Alright, so let me show you this real quick. I've done many experiments with this levitating coil. I have one video out there, a ½ hour long. All different coils, all different sizes, all different layers of aluminum. And these eddy currents, from my experiments, have shown to go into the walls approximately about 3/8 of an inch. Now, whether or not we change the frequency, the amount of power, many different factors maybe could affect that frequency. Anyhow, let me just show you this real quick. I'm going to plug it in. I got no switch on this, so I got to plug it in and unplug it. Ready? 3, 2, 1, go. It's levitating. Woo! Pull it out, pull it out. That snap was, when I pulled it out, this kind of went up in the air. Not too bad. Not too bad. I did this once. Funny. I should actually do it again. With this coil in here, I had dry ice inside there to help keep it cool. But this coil, I think, is way too heavy to accomplish that anyhow. It's funny because in the video where I did this, coincidentally, the second I plugged this in, the power on the entire block went out. Anyhow, I'm not going to say it was because of me. I don't know. This coil's neat. I forgot where I got that. Many people show it. But anyhow, okay. So anyhow, I just wanted to explain, because of my experiments with that levitating coil is what led me to know and try 3 layers of tubes inside there, because the eddy currents will create opposing currents in each one of those layers. So what if we have many more layers? There's all different possibilities, guys. Anyhow, so if you guys like magnets, man, go to my channel, go to playlists, and click on Amazing Magnets. And I got quite a few cool videos there of things you probably may have not ever seen. Hey guys, Paul Inventor 3 here. Just a quick update. It's not that late out yet. It's not that dark out yet, as you can see by the light background behind me. But let me just give you a quick update where I'm at and my I had more than this lit, but I was experimenting. I did many different experiments already off film, off camera. But they're pretty well lit, believe me. They are. And you would be able to tell that a lot. There, you could see. There you go. See my hand? I mean, it's no joke. They're bright. It's just a little... You don't want to look at a light in the daylight. I mean, come on. But you can see. These are very light yet. Alright. Anyhow, guys. Yeah, we're going to... Oh, I got so many ideas and ways yet that I know for 100% fact we're going to get this way brighter, many more lights, and we're still going to stay under 1 watt of energy applied. Alright, guys. Oh, there we go. You want to see how much... There's 4 of them over there, another 4 over here, yeah.